For number 7, looking at an annuity, we're going to be making monthly deposits, and we're trying to figure out what the amount should be of each deposit in order to have this amount of money in 11 years. I'm going to go ahead and walk through the help me solve this and talk about each step. So the number of payments, 12, because we're doing monthly, and 11 years. So 12 times 11, what is that? 132? Okay. So we're going to be making 132 payments, 12 each year times 11 years. The monthly interest rate, it's 3.9%, they tell us. And we divide by 12 because that's for the whole year is going to be 3.9%, but we're getting interest monthly, so you divide the interest rate by 12 because there's 12 months in the year. So calculate that out, and it comes out to 0.00325. So that's, you can think of that as your monthly interest rate, which over the course of a year then will come out to 3.9%. So our formula for the payment we should be making is given right here, and we have all the values we need to plug in. So our final value, we want to be $160,000. Our interest rate, since it's monthly, we've calculated our monthly interest rate is going to be 0.00325. We put that in here again. And then N is our number of payments. And again, monthly by 11 years, we had 132 payments. So use a calculator or use Excel here, and you'll figure out what your payment should be. And so I've typed in the formula into Excel, and you get $972.59 when you round to the nearest cent. Now the important thing is here to make sure your calculator is doing the math correctly, and you have to control that with parentheses. You want to make sure this is calculated correctly, and talk about a different way you could do that is to break it up into little pieces to make sure you have the parentheses right. So you have 160,000, and you want to multiply by this whole thing, so 0.00325 divided by, and let's go somewhere else and calculate what that bottom should be rather than worrying about getting all the correct parentheses. So the bottom should be 1 plus 0.00325 raised to the 132 power. So calculate that. So that answer we just got, -1. Okay? So that's what the bottom is. That to the 132 power -1. So now I can just put in here what that bottom should be, which is cell C3. So I put an equal sign in front of that, and it'll calculate it, and you get your answer. A lot of times trying to type this incorrectly into a calculator, sometimes the -1 gets taken off of the exponent. People type in 132 minus 1, and the calculator raises it to the 131st power and doesn't subtract 1 afterwards. Or doing this division, it just divides by the first thing and then subtracts 1 later from the answer. So it can be really smart to calculate this whole bottom part separately like we did here. And then when you're finally typing it in, it makes it a lot simpler. You're just doing 160,000 multiplied by this top part divided by the bottom part. And those are just single values now because you figured out and reduced. And if you look at number 8, it's going to be very, very similar. I pulled up the help me solve this screen again, but the formula you're going to be using is pretty much exactly the same. It is the same. So your final value, use the new final value. You're going to calculate your interest rate the same way. And then, yeah, plug the interest rate in and the number of payments. Again, you're doing monthly payments over the course of, in this case, 6 years. So there'd be 72 payments. But again, be careful when you use your calculator and make sure to type everything in correctly. I encourage you to, again, find the bottom part separately first and then plug it back in.